Welcome to Study Loop.
Okay, in this question, a block is on a spring. It's passing through the equilibrium position with speed v1, and a massive putty, is dropped onto the block, and it asks what is this mass, little m, so that the amplitude gets cut in half. Okay, so let's start off by talking about the initial energy here, E1, which equals 1/2 big M v1 squared, where this is the just the speed of the block without the putty. And this will be equal to 1/2 k a1 squared, which is the amplitude if the putty was not dropped on the block. Okay. The next thing we want to do is set up our momentum relation. So initially, the block has a momentum big M v1, and the final momentum will be the sum of the masses. So it's big M plus little m times some v2, some slower speed. Okay, so we can rearrange this to in terms of v2. V2 equals m over m plus little m. So these are both big M's here, times v1. And then now we can write our energy in the second case as 1/2 m plus m v2 squared. All right, let's replace v2. Let's inject this v2 in here. So then we have E2 equals 1/2 m plus m times big M over m plus little m squared v1 squared. All right, and this equals 1/2 m v1 squared times big M over big M plus little m. If we simply square out this term, so we actually don't need to square out this term, so this will cancel with one of these on the bottom. So it's easy to see that this that one of the big M's comes out front here, and one of the big M's stays inside of the parentheses. The reason we do this is so that we can rewrite this in terms of E1. So then E2 equals big M over big M plus little m times E1. Okay, so now we can rewrite our, on a new page here, we're going to rewrite our spring energy, so 1/2 k a2 squared. So this is the new displacement, the smaller amplitude, a2, will equal m over m plus little m times 1/2 k a1 squared. So the 1/2s and k's cancel out, and we are left with a2 over a1 equals the square root of big M over big M plus little m. All right, so we want to set this equal to 1/2. We want the new amplitude to be 1/2, and this implies that little m, if we rearrange and solve for little m, has to equal 3 times big M. So the putty has to be really heavy, okay? So now we substitute the value in. So we see how much energy is lost. We have to figure out what our new energy will be. So we're cutting the amplitude in half, the initial amplitude. So this equals 1/4 times 1/2 k a1 squared, which equals 1/4 times E1. So then the energy lost to thermal energy equals 3/4 of E1. Since we've only retained 1/4, we have to lose 3/4.